Question number 68. A parallel plate capacitor has plate area 20 centimeter square, plate separation 1 millimeter, and dielectric slab of dielectric constant 5 filling up the space between the plates. This capacitor is joined to a battery of EMF 6 volt through a 100 kilo ohm resistor. Find the energy of the capacitor 8.9 microsecond after the connections are met. So let's evaluate C. C equal to epsilon naught A upon D. So here dielectric is also there. So we have to write K also. So 8.85 into 10 to the power minus 12 into plate area 20 into 10 to the power minus 4 times dielectric constant 5 divided by separation is 1 into 10 to the power minus 3. Now, if we simplify, it will become 88.5 into 10 to the power minus 12 farad. Now, this is case of charging. So, Q equal to Q0, 1 minus e to the power minus t upon FC. So, we put the values. Q0 is CV, so that is 88.5 into 10 to the power minus 12 into voltage applied is 6 volt. 1 minus e to the power minus t. T is 8.9 into 10 to the power minus 6 divided by RC. So R is 100 kilo ohm, 100 into 10 power 3. Into capacitance, we have just found 88.5 into 10 to the power minus 2. Now, if we evaluate, these two values would be almost same. So this is 8.9 into 10 power minus 6, and this will come out to be 8.85 into 10 power minus 6. So we can assume them to be equal for making calculation easier. 6 into 88.5 into 10 to the power minus 12 times 1 minus e to the power minus 1. We evaluate 1 minus e power minus 1, where e equal to 2.73. So it will be equal to 88.5 into 6 into 10 to the power minus 12 times 0.63, which will be equal to 531 into 10 to the power minus 12 coulomb. Now, energy stored is equal to half 2 square upon C. We put the values. Q is this much. So 1 by 2 square of 531 into 10 power minus 12 divided by value of C. We have found it as this. So 88.5 into 10 to the power minus 12. So on simplification, it will be equal to 1.593 into 10 to the power minus 90. So that is our answer. Now, let's go to next question, question number 69. Here, C is 100 microfarad, battery 24 volt, and resistance is 1 million ohm. Plot qualitative graph between the current and time for the first 10 minutes and between charge and time for the same period. So let's evaluate Q equal to Q0 1 minus e to the power minus t upon RC. Here we can evaluate RC. So resistance is given 1 into 10 power 6 into capacitance is 100 into 10 to the power minus 6. So it is 100 seconds. So we have got RC. So time is given as 10 minutes. So we can find the value of charge Q equal to Q0. So Q0 will be equal to CV0. So 24 into 10 power minus 6 C into V0. This is 24, and this is V0 is here in our question. Here Q equal to Q0. So Q equal to CV. Capacitance is given 100 into 10 to the power minus 6. So this is 100 into 1 minus e to the power minus t. T is 10 minutes. 10 minutes means 10 into 60 divided by RC is 100. So we will get e to the power minus 6. So we can write it as 24 into 100 into 10 to the power minus 6 into. This will come to be this will be 0.998. So total value will be 23.99 into 10 to the power minus 4 coulomb. So we have got charge, and we can get current I equal to dq by dt. If we differentiate this expression, we will get this is CV0, and differentiation of this will be equal to T upon RC times e to the power minus T upon RC. So CC will cancel out. So V0 divided by R. V0 means this value of battery 24 volt means EMF supplied by battery into e to the power minus T upon RC. So we have already evaluated this e to the power T upon minus T upon RC, that is 6. So V0 upon R into e to the power minus 6. So we put the values. V0 is 24, R is 10 power 6 into e power minus 6 is 0.0025. So this will become 5.9 into 10 to the power minus 8 ampere. Now we have to plot the graph between current and time for 10 minutes and between charge and time. So if we plot the graph for current and time, so we have got the value of current as 5.9 into 10 to the power minus 8 ampere at t equal to 10 minutes. So graph will be like this, and this value will correspond to 10 minutes. It will come little lower and down. And this point corresponds to 5.9 into 10 to the power minus 8 ampere. This is time axis. This is current axis. Ampere. Now, if we plot the voltage time graph, charge time graph. So this is Q, this is T. So graph will be like this. This value corresponds to T equal to 10 minutes, and the corresponding value of charge for 10 minutes we have found as 23.99 into 10 to the power minus 4 coulomb. This is Q in coulomb. And the time is in minutes. Same is to here, time is in minutes. So this is solution to question number 69. Now, consider question number 70. How many time constants will elapse before the current in a charging RC circuit drops to half of its initial value? Answer the same question for discharging. So here, I equal to I0 divided by 2, and this is case of charging. So Q equal to Q0, 1 minus e to the power minus T upon RC. Here, from here, we will get I equal to I0 times. This is charge. So if we evaluate it, so it will be equal to I0. What do? We divide it by time both sides. So I0 and 1 minus e to the power minus t upon RC will be there. And in our question, I is given as I0 upon 2. So we write it here. I0 upon 2 equal to I0 times 1 minus e to the power. Suppose t equal to and RC. Because question says how many time constants? RC is time constant. Suppose n time constants are there. So n times RC divided by RC. So this will become 1 upon 2 equal to 1 minus e to the power minus n, or e to the power minus n equal to this 1 by 2 can be subtracted to others. It will be 1 by 2, which gives e to the power n equal to 2. We take log of both sides, and we know that log e base e is 1. So it will become n equal to log 2 base e. And log 2 base e is 0.69. Now, for discharging circuit, this relation will change to I equal to I0 times e to the power minus t upon RC. And other constants will be removed from the sides. So now, given I is I0 divided by 2. So I0 divided by 2 equal to I0 e to the power minus t upon RC. So this will become 1 upon 2 equal to e to the power, and then we have to take t equal to n times RC. So e power minus n will be left, which gives e power n equal to 2. We take log, so n equal to log 2 base e, and that is 0.69. So in both the cases, answer is same. Thank you for watching.